How to test automotive sensors, power, ground, signal, and scan data. This lesson shows how to approach sensor diagnosis fails when power, ground, signal, and scan data are tested as separate guesses instead of one system. Sensor diagnosis fails when power, ground, signal, and scan data are tested as separate guesses instead of one system. The problem is not usually one isolated term or one quick check. It is the relationship between power supply, sensor ground, signal voltage, 5-volt reference, and the evidence you collect from the circuit and scan data. Start with normal operation. Establish expected circuit operation, sensor ground, signal voltage. Before diagnosing a fault, define what the circuit or data should do when the system is healthy. This gives every later measurement a target, so the technician is not just looking for a number, but looking for behavior that matches the system design. The ECU judges sensor input by voltage behavior, plausibility, and scan data relationships. The module does not see guesses or replaced parts. It sees input voltage, signal behavior, plausibility, and whether the data matches the operating condition. That is why this section turns the physical circuit into the logic ECU or module can actually use. Now zoom into the circuit. Power supply, sensor ground, and signal voltage are separate checks, even though they work together. This close-up keeps the focus on pins, probe points, and what each wire is supposed to prove. Scan data has to match the circuit. A sensor value should move when the real condition changes, and the measured signal should agree with what the scan tool reports. If those two views disagree, that disagreement becomes the next diagnostic clue. Signal voltage must agree with live data and the real operating condition. Multimeter for power, ground, signal basics. Scan tool for live data comparison. Measurements matter most when they are tied to the expected condition and the exact point the ECU uses for its decision. A reading is only useful when you know what the circuit was supposed to do, where you measured, and whether the system was loaded or changing at the time. Common faults can look similar from the scan tool side. A failed sensor, a weak ground, a missing reference, or a connector problem can all make the data look wrong. Comparing sensor fault against wiring fault prevents one symptom from becoming one assumed part. Build the test path in order. Step 1, identify pins. Step 2, check power. Step 3, check ground. Step 4, check signal. Step 5, compare scan data. Step 6, confirm real behavior. This sequence turns the lesson into proof instead of guesswork. Do not replace the sensor yet. The takeaway is to prove power, ground, signal, and scan data first. If those checks agree with the expected behavior, then the sensor becomes a stronger suspect. If they do not agree, the circuit or data path is still the story. Step Diagnostics. Guided automotive diagnostics.